let's now begin a substantive part of our event. Let us meet the first speaker. Professor Konrad Lewczuk from Warsaw University Technology is a recognized academic and practitioner. He is the leader of many innovative simulation projects in logistics and production and has been collaborating with Intermarium for years. Today he will share his insights in a presentation that opened the expert panel of our event. Please welcome Professor Konrad Lewczuk with a big round of applause.
Ladies and gentlemen, before I'll start my presentation, I'd like to give the many thanks to the organizers for having me here and for asking me for the presentation here. I find it as an honor to be here and share with you some of the insights from my experience and from my work with the presentation. And I would be glad to share them with you, those who are the practitioners of the simulation and also those who want to check if the simulation is a proper tool to be implemented into your business activities, in the industrial projects, and the other ways you want to check if the vision is ready to be changed into an impact. As it was presented, my name is Konrad Lewczuk. I'm from Warsaw University of Technology, Faculty of Transport. When I do with my colleagues simulation, I use the simulation as a tool not only for the research and education, but also as a tool for business projects that we are dealing not only with the faculty, but also with our colleagues from different bodies. I used the simulation from the 2016, so it's like 9 years to this moment, and I was observing the FlexSim as it is changing, as it is evolving, and when it became to this final stage, as we can see it here, I must say that the change is dramatical, everything that was implemented during that time that made the simulation much easier. And today I would like to give you the presentation about the insights, how the simulation accelerates success, how it helps to change the vision that we have at the very beginning to the impact that is at the end. But before that, let me just describe the perspective of mine, because we are different specialists. We are using the simulation in different ways, so we understand it differently, and we also expect different outcomes from that. I am a scientific and engineer. I am in modeling and optimization of logistics, especially intralogistic systems. And in this case, I specialized in automation for warehousing industry. This is my area of interest, and most of my models touch this area of logistics. This is, just like I said, the way in I use the simulation to do the project, to teach the students, and also to do research. There is one more thing I'm interested in. This is the informatic systems for logistics and supply chain, especially for warehouses. I am a consultant in WMS, so always when I introduce the new concept of a model, then I implement there some kind of a WMS logics to keep it as possible close to the real warehousing systems. The agenda of this presentation is as follows. Firstly, I'll try to present you some visions, some projects, the 4 of them that we are realizing during the last years with a cooperation with our industry partners. And then I'll try to tell you how I see the simulation as an enabler of that success. Then we will try to follow how the vision changed into a real impact, and this impact can be measured and is a factor affecting the business in real time. After all, a few words about the emerging trends and conclusions to the presentation. What is the future of simulation, in my opinion, and I hope you will disagree with that and we'll start the discussion after all. Okay, every project starts with a vision. This vision can be a result of a problem to be solved, can be a result of some kind of imagination. It is usually related to the business we serve. It is also related to the specialization we have, and in most cases it's also constrained with the budget we're disposed to do. But in the case of industry, industrial logistics, in the case of warehousing systems that I specialize in, this kind of vision will be a kind of installation system, the facility that combines installations and systems of different types. It can be also the process to be implemented within an existing system. But in all these cases, realizing the vision faces many challenges that must be overcome. In the case of intralogistics and warehousing systems, we are dealing with a complex technical system consisting of the number of different objects that are interfering itself, are influencing itself, and existing in one single installation. Often, this coexistence is of a random matter, so it's quite difficult to find out what will be the final result of this kind of material flow in the system and what can happen if the randomness is applied to a large-scale system. Therefore, these systems are difficult to be predicted, to be configured, and they also can be constructed with using different but comparable technologies. And the difficulty is in details that are differentiating the technologies. The same technologies can be applied in similar conditions, but under different charges and load, they will give us different results as an outcome, finally. There is also a question: who has the vision, who proposes the solution to the vision, and who brings it to the life? These three bodies need to discuss fluently and find out the common point of view, and I think that the solution could be a simulation in that case, to connect the one who has the vision, who solves the problem, and who implements it in the real life. In addition, there are issues with providing and queuing data for the simulation, with the sources of data, configuration of data, the sets of data which are necessary. Today we are dealing with data overload. We dispose a lot of data, but we are not able to select which of them will be necessary and appropriate for the simulation at a particular level of detail. And this all can hinder the implementation of the vision after all, but the simulation, in my opinion, can help us in doing that. Now, let me introduce you 4 different visions, 4 different projects. 3 of them were realized with a cooperation with Metroplan and Rossmann. Rossmann is one of the biggest distributors of cosmetics and drugstore here in Poland and, of course, in Europe. The first one was a new large-scale automated warehouse facility. This is a project of a type of a greenfield, which was planned as a response to the lack of efficiency of existing installations. The second one was mapping the existing automated installations of that Rossmann to build some kind of digital shadow. The third one was a radical concept of a new order picking system, also by Rossmann, to check if there are new possibilities in a new way of doing order picking in the highly complicated distribution process. And the fourth one was completely different. There was a project in which the vision was to check if you are able to use the simulation for ergonomic research and finding out the best configuration of working stations for the couriers working in one of the logistics operator firms in Poland here, with using the virtual reality. So we have 4 projects, 4 visions now. And all these visions, these projects, they have this common point. They are complex, dynamic systems of many variables with random phenomena included. Now, to solve that problem, we can apply, let's call this standard methods. These standard methods will include the analytical approaches, such as calculating the efficiency, productivity, and costs with paper and the pencil, with an Excel in most cases, of course, the basic tool of all engineers of all the times, estimating the performance and selecting the KPIs to be included into project. We will also likely enlist the support from consultants who enrich the project with their external knowledge and experience and the fresh view, so in the base of different projects realized to compare with. This is also the base for the benchmarking of the project. Or the organization will want to implement the project by itself, but then we risk repeating the existing errors and insufficiencies in our assumption to the process. Or at least we can adopt a copy and paste solutions from the well-known situations to the new situations, just counting on the positive result on that. However, all those methods, while necessary, do not provide what simulation can do. They do not give a complete picture, a complete representation of all the relevant factors in one place, in which they can be considered together as a complex systems of independencies. Now, who is using the simulation in the process then? All three parts, all three stakeholders of that process are interested in simulation. The client can use that, the owner of the vision can use that to trigger that vision, to check if it's suitable for realization, whether it will be an option to be done or not. Then the suppliers of equipment are always using the simulation to cover the needs of the clients and check if they are fitting the assumptions from the basic projects. And after all, the third part is a consultant, which is also always engaged in the process to check if the assumptions of the clients are appropriate and the propositions of a supplier are fitting these assumptions. So the simulation can be applied in these three stages at all. And then there is a wide area of working with that. Now, what are the advantages of a simulation in this kind of a project? Outraging this, let's call standard methods. Firstly, simulation is to track the bottlenecks. The bottleneck, especially in the automation project in which we are dealing with automatic installations in warehouses, are one of the most common problems to be tracked of. And we need a kind of a visual model to track by the finger where are the bottlenecks that are hindering the process and checking it and making it inefficient. This is always this one crossroad, this one conveyor, which is making the traffic, and by the type of bullwhip effect, it influences the rest of the process, so the tracking of the bottlenecks. The simulation can be used as an interactive modeling solution. All three parts of the process can use the same visual model to check all their necessary assumptions. The client will see the next steps of the project. The consultant will propose new solutions. The supplier of the equipment will propose different solutions if necessary. So the simulation will be a tool for communication between the partners. It will also allow us to focus on the rational solutions from the very beginning. If we do an initial simulation of a system, then from the starting point we can cut the solutions that we are not finding appropriate, then lower the number of iteration process in designing and just focus on those which are of the highest quality and we want to have them and when to have them. This is also related to what-if analysis. This what-if analysis is a little bit different than we know it from the digital twin, because at the design stage, the what-if analysis means checking the influence of the changes to the project by using it in the simulation. It also incorporates the randomness. The accumulation in material flows, in decisive flows, in the different periods of the time of the day, of a week, in example, these are the most important problems in the projects for automatics in warehousing industry. And these accumulations, they must be tracked under the different patterns of stochastic distribution of phenomena in the models. Then it is also for process mapping. It is the tool that allows us to represent not only the process flow itself, like BPMN or the flow diagrams or the spaghetti charts, but it also incorporates the logics of the process, as well as structure of data, which is necessary to take the decision, and the sources of data. So the map of the process can be multidimensional in this case. Then we are using the simulation to test the logics and to verify the KPIs of the project and mitigate the risks at the very beginning. So we can be not almost, but sure that we can be almost sure that the main risks can be deleted at the very beginning of the project. Okay. Okay. Now, simulation can be applied at various stages of a system lifecycle, with, of course, different objectives and applications at each stage. Once the system becomes operational, it can serve as a benchmark for monitoring and auditing, providing a reference against the actual performance when it is assessed. When performance issues arise, simulation can confirm observations and support preliminary analysis of potential solutions. In subsequently detailed simulations of selected alternatives, they enable the development and validation of concepts while also facilitating information exchange among the stakeholders. And in advanced stages of the project, of the life cycle, simulation can be applied for a final testing, and when supported by tools emulating the components of physical and IT elements, especially this is important for WMS system implementation. It can also support integration and preliminary testing. Ultimately, the simulation may evolve into a digital twin or the digital shadow. Yesterday we had quite interesting discussion about what the digital twin is, what the digital shadow is, and we found out that everyone has a different definition of that. I encourage you to find out your own definition and compare it with others. You'll be surprised how different are the definitions of us. Okay, but we can assume that simulation model can become a digital shadow at all, or digital twin. It depends on the definition we use that, and can be then applied as support for audit, analytics, management, and operational decisions, so the loop is closed. Again, we are triggering the process from the beginning. Of course, the simulation is a toolbox also. We can add different types of tools to that. Now we are discussing adding the artificial intelligence on the different processes. Also, on the margin, look for your own definition of artificial intelligence and check how we understand that and how we put it into our projects. Because in most cases, we use the artificial intelligence as just a word that is busy around without actual relation to the projects we do. The simulation is a surrounding for virtual reality and augmented reality. These are the elements of digital transformation now. So if your companies, if your businesses are going into digital transformation, you need to take account the simulation as a ground, as a base for the development of further functionalities. Now, the simulation, as in FlexSim, it's a kind of an open source tool to implement all kinds of logics, algorithms, and methods we want. Of course, to do that, we need to know the basics of the simulation and to know the basics of our business to combine them into working model. But now, after this beautiful picture of a simulation, as a tool, let's jump into practical applications that I have presented to you previously at the beginning of my presentations. Let us review these 4 real-world cases and examine which simulation features were applied and the value they delivered after all. So, the first case was concerned a brownfield type of the project in which we were designing from the scratch the new object on the investment plot of the owner. That was a Rossmann in that case. There was nothing more than the restrictions of the land and performance assumptions for the new project, and also some ideas about the technology to be implemented in that case. At the concept development stage, simulation was employed to support the traditional plant design process. It verified the plant's performance and parameters after all, and it was used to introduce technological adjustments to the design, conceptual design at this moment. And at this stage, the simulation model was considered as a contact platform for the design teams from all 3 sites that we were taking part. The simulation also facilitated industry coordination. This is quite important part of the designing of warehousing facilities when there are different installations to be compared and to be placed in the common space. This is the architectural, this is electrical, this is water, this is heating, and this is also the technological installation that must exist in the same place. And as you probably know, none of the specialists will do one step back because their installations are always the most important. So this is how it works. On this also stage, the simulation was used as a background for the WMS warehouse management system and material flow control system frame to check out the necessary functionalities of that systems and also set the decisive points for these systems in the physical architecture of the installation. Then, in the second case, the primary goal was to map the existing complex of automated installations and build a tool that would support the ongoing operations of that facility. We can call it a digital shadow, despite the definition of that. We can call it a digital shadow, which can be used to identify the bottlenecks in the ongoing operation or to do a kind of what-if analysis after variable conditions of operations and different processes that can be organized within that. The model was designed to answer what-if question and to do insights for everyday operation. In this case, simulation became also a tool for a process mapping, provided a deeper look into the system and understanding of the mechanisms of this highly complex automation installation. Then, the third project was to test the concept of goods-to-man picking system within the Rossmann installations, which could be considered as a revolutionary change for that kind of the business in the distribution center. Because the project did not establish any technological constraints for that task, beyond basic performance assumptions, there was no land restrictions and cost restrictions. The simulation in this case was used as a sandbox in which plenty of different options were tested to check which of them will fit the final requirement of the client. So finally we found what will be the best solution, and that was the ground for calculating the space efficiency of that, the number of people to be hired, as well as estimate the investment expenditures to construct that kind of an installation for a client. So the simulation in this case was treated as an analytical tool. And in the fourth example, in the last case, a simulation model was equipped with a virtual reality layer and served as an environment for ergonomic research of the workstations. That was used to test the workstations of the couriers loading their distributional vehicles every morning. They were just hurting their backs. They had problems with the legs. So the simulation model could be used to check if their positions, if their environment is appropriate for their work. This model was prepared by Patryk Żuchowicz. I don't know. Yes, Patryk is here. So one of my colleagues from the Intermarium, we did that research together, and it was quite scientific research on that case, to the opposite to the previous three I have presented to you before. And now, what was the impact? We have the visions, we have the implementations, now the impacts. All 4 projects presented were implemented, and their impact can be assessed. New large-scale automated warehouse facility. In this case, the simulation allowed us to confirm all the assumptions. So the project jumped from the concept stage to the realization stage, and the simulation helped us to improve the basics of the first project, so to make it consistent with other installations and efficient in a way that we can follow the material flows in that. For the mapping existing automated installation, this tool resulted in regular what-if analysis, which were realized before the big, let's say, actions, distribution actions, and before big changes in slotting, in the organization of stock and organization of work. It was also used to analyze the efficiency of the system under different occupational conditions, like a number of people required, and so on. In the third case, this radical concept of a new picking system was unfounded. We have proof that this concept for this particular usage is not appropriate answer. So, completely different strategy was then accepted for the order picking process in our partner's distribution center. And for the ergonomic workstation, a new system of testing workplace ergonomics was designed, and insights from that research will be published and publicly available to you if you want to know a little bit better how to construct the workstation for the couriers packing their vehicles. But there are also other types of impact that can be mentioned here. Every organization that invests in a simulation embarks on a digital transformation path and acquires new technological and managerial competencies. Especially within the area of Industry 4.0 and 5.0, which are now the common trend of developing the business all over the world. Besides this, the impact of using simulation can be considered in terms of return of investment, efficiency, sustainability, resilience, flexibility, adaptability, and all these words that are common in our practice. But after all, the most important part is supporting the decision to be made. The proof for the decision, which is undoubtedly the help to mitigate the risks on the investment. And now, on closing, emerging trends and conclusions from my presentation. I consider the simulation as a critical factor of Industry 4.0 and 5.0. Of course, at this moment, we are calling the Industry 5.0, but you know that this is kind of an old thing because it was released in 2011, so the ancient times. Now the 5.0 industry is a cooperation between the human and the machine on the one ground, on the one platform, is active idea. And the simulation will make a ground for that, since it enables us for augmented reality, for virtual reality, and for other applications of the world this digital world to the real applications. It is a cornerstone of modern manufacturing and logistics now. There is no big project in the warehousing industry, in the automation, without the simulation, because there is no other way to comprise all the random factors that are influencing the material flow in such a complex installations. We are now introducing the different aspects of AI into simulation models and into digital twins, after all, to support the decision-making and independent decision-making also, but this kind of solutions. And what is important also, the simulation now is integrated with existing legacy systems. The systems that we are operating in our businesses, and we are looking for the way to do that. Yesterday we had a quite interesting meeting with the representatives of Autodesk, which we have here today also, as I think. And we were discussing how to incorporate the simulation into the everyday practice, how to put it into our IT and OT systems and use it as an everyday tool to support our work. Now, this is the future. This is the future which leads us to integration of simulation with different ecosystems of software, like the ecosystem of a software from Autodesk or our legacy systems in our businesses. What are the barriers? Of course, there is a cost. Always there is a cost. Some will call that cost high and others will call that cost low. It all depends on the perspective. If you have in your business the team that is in the simulation, you both the tools, you both the software, then there is no cost. There is only a benefit. If you are considering getting into simulation and incorporating it into your business, then of course the cost will happen. But I'll encourage you here to consider the scale of the cost and the scale of the potential benefit at the end. This is a very good investment, in my opinion. Of course, other barriers, the skills, the quality of data, the culture of working, of operation. These are all to be considered. But as you see, I put the simulation between the vision and impact, and I think that it is one of the good tools to be considered as a support to come from vision to the impact after all. Thank you very much for your attention. I'm very sorry that I was 2 minutes after the time, but I hope that was informative for you. Thank you very much.